Hello, I hope you all can hear me. Hello, can you all hear me? My voice is low. Okay. Now, can you hear me now? Great. So, hello everyone. I'm Geraldine, and I currently lead the ACMW community in VIT, Vellore. And I'd like to begin by welcoming you all today. I hope you're having a nice time with us with the hack. Let us know in the live chat or the comments. And without further ado, let's get to the main purpose of today's session. We have Professor Gana Progebna, who will be here with us today, and she will be speaking on behavioral data science. She's currently a behavioral data science lead at the Alan Turing Institute, which is based in the UK. And she's also well known for her YouTube channel, Data Driven. I'll leave a link in the description in case you guys are interested. And she is very knowledgeable and very experienced, and she will also be looking into your submissions today. So today, the ones you'll send in tomorrow. So oh yeah, I have to tell you also that the live stream, during the course of the live stream, we're going to have a Q&A session as well. So that will be towards the end. So you guys can save up all your questions and ask her in the end so she can enlighten you with her answers. So without further ado, Gana ma'am, we are so grateful and we are ecstatic to have you join us today. And the screen is yours. Hear me?
Well, hello everyone. I'm just going to wait until my stream loads. I hope you can hear me. So if you hear me, please write in the chat. I'm monitoring it. Oh, okay, awesome. So you guys can see me. Fantastic. All right, can you see my slides as well? The slides should be behind. Okay, fantastic. So I'm going to monitor the chat during this session, so feel free to write your questions as we go along. Sometimes there might be a delay between my answers and the time when I receive a question. So, but you have to forgive me because, this is obviously a live session and there is a little bit of delay. Fantastic. All right. So, let me just, so again, thank Geraldine and the team for inviting me. And just as a matter of introduction, I just wanted to say that, I lead a behavioral data science stream at the Alan Turing Institute. And today we will be talking about behavioral data science and diversity and inclusion projects. And I'm going to give you examples of 2 projects that I have done recently. And we are actually going to talk about methods that you can use to conduct these projects. And in particular, I'm going to talk about natural language processing. And I know that you guys are very knowledgeable about it. And there are a lot of, in preparation to today's session, I discovered that there are quite a few materials online. You can obviously find a lot of information and effectively, there are many tutorials that you can use. So instead of giving you a tutorial on how to essentially use Python and do the coding, I'm going to talk about the methods that you can use and how to select these methods, because I think there is a real lack of information. I don't know if you guys can see me and my slides. If you can you please tell me in the chat? Because I cannot see myself. All I see is, if you can see me, this is the picture that I see of myself. So just give me a shout if it's working. Oh, awesome. All right. So today's topic is how to design a behavioral data science diversity and inclusion project from scratch. And I know that many of you would not be familiar with the behavioral data science methodology. So just as a matter of introduction, so I studied, my original area of expertise is not actually data science. So I came to data science from a social science stream. So initially I studied economics and psychology, so behavioral science. And then gradually I kind of started learning data science. Currently, my research is very, very mathematical. But today we're going to do something very simple, just to start with. And as we go along, I will explain to you what I mean by behavioral data science and what we normally do in behavioral data science as well. All right. So if we look at behavioral data science, in general, this is a new field that kind of emerged from data science, from the data science perspective, and from behavioral science perspective. So from a synergy between behavioral science and data science. And just to show you why behavioral data science eventually turned into behavioral data science, here is some Google Trends graph for you. So effectively, if we look at the development of behavioral science and the number of searches for it, they're kind of fading away. Not many people are doing that, but AI, machine learning, and data science obviously are a lot more popular. So effectively, as economists and psychologists, we realize that there is a lot of data out there, and we can actually use this data to be able to understand people and systems better. And this is how this new field of behavioral data science was created. Let me actually kill myself probably on the screen so you could better see my screen. All right, so here we go. All right, so in terms of behavioral data science, what exactly is the focus of behavioral data science? So behavioral data science deals with three types of behaviors. It's algorithmic behavior, human behavior, and systems behavior. Or on my screen here, it's basically humans, algorithms, and systems. So we have a theoretical methodology and we have practice, right? And in terms of talking about methodology and practice, there are normally a lot of misconceptions about behavioral data science. Many people confuse it with business analytics, and actually if you search for some articles on Medium, you will probably find people using the words behavioral data science and business analytics interchangeably. I just want to say that that's not the same thing. So behavioral data science is a separate field. And what we look at when we talk about behavioral data science, we usually talk about humans, algorithms, and systems. So in terms of humans, so we have research from social psychology, cognitive psychology, and behavioral science. And effectively what we do is we contribute to our understanding of humans, to the theories that we have in psychology, by looking at data, so what people actually do. And I'm sure you know that we all produce tons and tons of data daily, so every second of every day. And of course, as behavioral scientists, we want to look at this data in order to understand what it is that people do. Then we have algorithmic behavior. So algorithmic behavior is pretty cool because we can look at two aspects here. The first aspect is we actually have mathematical models that are classical models. For example, that's that model pandemics, right? So currently this is a very hot topic, how to understand the spread of a disease. And these algorithms are kind of classical mathematical algorithms, but they can explain human behavior and they can explain behavior of complex systems. So in that sense, part of algorithmic behavior strength and behavioral data science is exactly... Sorry, did I... Hello?
Great. So, hello everyone. I'm Geraldine, and I currently lead the...
Okay, sorry, I think that my my live stream is really delayed. Let me just get back. Okay, so I'm just gonna go ahead then. I think I think my live stream is being really slow. So I'm going to look in the chat. Sorry guys, I just got a little bit distracted because I saw Geraldine on my screen again. All right, so I'm gonna continue with algorithmic behavior. Yeah, so in terms of algorithms, we look at these classical models, but we also know that various machines, robots, they effectively at the moment are developing, and they have behavior of their own, right? So they effectively communicate with humans, and we have various conversational AI. We have interesting robotics projects. We have things like driverless cars, and all of these things are algorithms, right? And of course, they have behaviors of their own, and it is interesting to see what exactly these machines are doing. So one of my colleagues is doing a project on IQ tests for machines, and it's pretty cool because you can actually get machines to communicate with you, and you can design an IQ test to understand which algorithm is smarter. So what she's doing is she's interviewing, for example, Siri and Alexa, and she's developing these tests, kind of IQ tests for machines, which is super, super cool. And then the third strand that we have in this in behavioral data science is systems. So systems, they combine humans and algorithms, and we look at how complex systems work. Right? For example, smart cities or transport systems or something along those lines. So effectively, when we have collaboration or some sort of interaction between humans and machines. All right, so that's kind of very, very brief introduction into behavioral data science. I'm going to come back to it soon when we talk about methodology. But now I want to turn to the focus of today's exercise, and that is going to be diversity and inclusion. I know that in the hack you have several tasks that are diversity and inclusion related. And I want to say that today I'm going to just concentrate on gender and race. First of all, I have to make a footnote that race and gender are very complex issues, so we need to focus on something to start with. So today I'm only going to concentrate on women. And in terms of race, I'm only going to concentrate on Black people for the first project. In the second project, we will look more broadly at various groups and various genders and various races. So I just wanted to make this footnote that, of course, modern sociology says that gender is non-binary, and we can't just talk about women and men. But for the first project, we will talk about women and female representation in leadership roles. And then we also will talk about race. In particular, we will talk about Black people. And we will use natural language processing to help us, and I'm going to explain how it all comes together. But first, let me motivate my first project that I'm going to talk about today. And basically, we know that humans are biased. Right? We know that humans are biased in general in different life areas, and this is extremely important. So as you know, we recently had Black Lives Matter movement that was very influential around the world, and here you can see basically on your screens the leads of Black Lives Matter. That's 3 women actually: Patrice Cullors, Alicia Garza, and Opal Tometi. So they started this movement, and this movement effectively showed that we have a lot of police brutality against representatives of Black African American community. So this movement started in the States mostly, but as you probably know, later this year we had various events all over the world that were sparkled by police brutality towards representatives of Black African American community that were organized by Black Lives Matter. And then at the bottom of the screen, you also see 2 other women, that's Sharda Davis and Joy Melody Woods. So these women are academics. So in academia, we also have a big problem with racial representation. So if you are, white male, you have a lot more chance to be successful compared to, if you're, for example, Black female. And these 2 women, they started a movement that is called Black in the Ivory, and the focus of that movement is on women in academia, saying that there are a lot of there's a dominance of white males in academia, and they wanted to attract attention to the gender subject and to the racial subject. So effectively, in various areas of life, people tend to be biased, and they're also biased in the workplace. So this is a person from my Twitter feed, Brandy Riley, and I absolutely love this tweet when she wrote that. And effectively, when we had the Black Lives Matter movement, the recent campaign, a lot of people were saying that, I'm supporting this campaign, and they were posting like Black Lives Matter graphic where it was just a kind of a box with kind of black color inside, so it was effectively a black box. A lot of people were posting this, and she was when she was commenting on it, she said, well, thank you very much for the Black Lives Matter graphic. May I please see a picture of your executive leadership team and company board? So what she meant by this is that, well, many people show solidarity, but actually very few people have enough representation of Black women in the boards. And to illustrate that, I mean, this is, if we look at Fortune 500 companies in this table on the right-hand side, you can effectively see all women that we have on the Fortune 500 list. So out of 500 companies, we only have 37 companies led by women. But I mean, if we also zoom into race, then you will find that only 3 of these women are women of color, and none of them are Black. So just think about it. We have top 500 companies in the world, and none of them are led by a Black African-American female, which is, of course, a big problem. Right. So this is, I mean, when we talk about humans, so humans are biased in general, and they're biased in the workplace. But we have similar problem with algorithms. Algorithms are also biased. They're biased in general. And this is one of my favorite examples. You probably have seen it on Twitter or on other social media. So this is effectively the picture of President Obama, pixelated a little bit, and we have a reconstruction of this picture done by a deep neural network, and the result, as you can see, is a white guy. So the reason why it is a white guy is that the training set that was used in this particular case was not appropriate to actually reconstruct someone who is a Black or African American male. So we have a lot of data in facial recognition algorithms, and if you have done facial recognition algorithms, if you try to do them, try them definitely. If you have done it before, you probably know this. But basically, I work a lot with images, and I can tell you that in principle, we have technology to be able to distinguish people of different races. However, the problem is that normally you have to write a separate algorithm for each race. So we could write an algorithm that would be very, very precise and will be recognizing Black African-American community, representatives of Black African-American community very well. But at the same time, this algorithm will not be able to recognize white people very well, right? So the challenge here is to actually construct an algorithm that will be universal to different races, right? So you probably heard of various horrible things happening to representatives of Asian or Chinese communities in the airports, in some places where facial recognition was used. And effectively, this is because, the algorithms do not recognize them very well. I think the community that we struggle with most when we talk about facial recognition actually are the community of Black African American females. Because we do not have very good training sets. The training sets are usually incomplete and very small, so it's very difficult to train an algorithm. But I just want to say that the problem is not that we cannot train the algorithms, we can. And we can write very, very precise algorithms for recognizing different races. It's just the challenges to actually write an algorithm that would recognize for example, representatives of Black African American community and white community simultaneously. Obviously, there are also many ethical issues with facial recognition, and these issues are so deep that some of the big companies are no longer engaged in facial recognition exercises. For example, IBM. So this is an actual title from the paper, where IBM has recently announced they are no longer working on facial recognition because it is used for racial profiling and other unethical things. So, basically we see that in some cases the use of algorithms is intensifying, and we see quite a lot of unethical use of algorithms sometimes, and this effectively causes many companies to think twice before they engage with this type of technology. All right, so the point of showing you this was to say that algorithms are biased in general, and they're also biased in the workplace. Well, one of my favorite examples of biases in the workplace is Amazon Amazon hiring algorithm. So this algorithm was trained using software engineering CVs. So basically, Amazon was hiring some software engineers, and they just all happened to be male. And well, not all, but the majority of them were male. So then Amazon decided that they will pre-screen, because they're obviously getting thousands and thousands of job applications every year. They decided that they are going to use an algorithm to pre-screen these applications and select people for an interview based on an algorithm. And in fact, you can actually, if you interviewed for various companies, many large companies these days, they run this virtual interviewer system where you are interviewed not by a human being, but you are interviewed by a robot, by AI. So Amazon didn't do that. They just collected CVs like you normally would. And what they did was they effectively trained the algorithm on inappropriate data, because the data was inappropriate in the sense that there was a huge gender bias towards men in that training set. But when they trained it, the outcome was that if a woman would apply for a post, this would result in discrimination, because effectively the algorithm was picking mostly male applicants. So the reason for that was, if you had on your CV something like female college or women's college or something like this, then you would actually get an unfavorable treatment by an algorithm who was obviously expecting male applicants. And, the problem also was that when this bias in the algorithm was discovered, Amazon actually didn't do anything about it for a long time until a huge wave of disagreement appeared in the news, and effectively, they had to change it. Here's another example. Again, this is from my Twitter feed, and I think it's a fantastic example of training an algorithm, an image algorithm on incomplete data. So effectively, what this algorithm is doing is it is selecting unprofessional haircut or unprofessional hairdo. And as you can see, all the white pictures are considered to be professional hair, but all the black pictures are considered to be unprofessional hair. So again, this is a result of training your algorithm on incomplete or inappropriate, inadequate data. Okay, so let's basically try to go into these projects, but before we go there, I want to tell you about methodology. So when we talk about behavioral data science, like I said before, it's a combination of behavioral science and data science. And the difference between behavioral science and data science is the same as the difference between a conceptual and a methodological fields. So conceptual fields, well, think about mathematics and engineering. So mathematics is a conceptual field that basically writes models and theories, and engineering is an applied field. In engineering, you're thinking, okay, how do I apply a particular model? How do I solve a problem, right? And behavioral data science effectively is a combination of this conceptual and methodological approach. So in terms of how you can construct behavioral data science models, the first thing is you can enrich conceptual frameworks with data science methods. So this is effectively when we have a psychological theory or behavioral theory, and then we use a large data set to test this theory. Right. Then the second option is you start with a machine learning or computer science model, and then you're trying to enrich it with the methodology from conceptual models coming from psychology or behavioral science. And the third strand, so this is a strand where I work, most of my work is in this area, is hybrid models. When we effectively combine models from behavioral science or decision science, and we take machine learning models and we embed our decision theory into machine learning model, make a hybrid, and it's normally a lot more powerful. So I work a lot on suggestion systems. So by combining decision theory with a neural network, for example, you can get a lot higher satisfaction from customers or from general public with suggestion systems compared to the algorithms that we normally use in computer science. So these are very, very useful algorithms. Unfortunately, they're a little bit too complicated for an intro lecture. So for an intro lecture, I'm going to talk about a very simple thing. This is natural language processing. And I'm sure you all heard about these concepts, maybe not, but you heard about some of them. So when we talk about natural language processing, we have quite a lot of choice in front of us, right? So we have models that come from statistics. This is LDA and NMF, so latent directly allocation algorithm, and non-negative matrix factorization. So that's a statistical models. You don't actually train them, you just apply them, right? And then you have things like BERT, RoBERT, DistilBERT, ExcelNet. So these are all transformer type of algorithms that you train on some sort of data, and then you apply them. So there are fantastic tutorials on each of these algorithms, and you can find them on, for example, Towards Data Science. There are many writers who kind of post post tutorials on this, and there is a fantastic one of my favorite tutorials on Bert and Roberta. Was actually done by Abhishek Thakur, who is Kegel 4 times Kegel Grandmaster. So you basically, I'm sure that you worked with some sort of natural language processing algorithm before, but I think most people do not understand how to select an algorithm. Like, why should we go for latent Dirichlet versus Bert or Roberta or distilled Bert? So how do I know what to choose, right? So this is the type of question that you normally face. So, and oftentimes what I find is many people just choose an algorithm at random. So they go, they do a search for NLP online, something comes up, they go and they simply apply stuff that they find. So instead of doing that, you always need to be very, very clear about what it is that you're trying to do in your project. And you need to apply an appropriate algorithm, an appropriate method to your data. So as you can imagine, for all of this, we need verbal data, right? So what are the advantages of these things, like latent Dirichlet allocation? And in fact, in the projects that I'm going to show you in the next few minutes, I'm going to use exactly this latent Dirichlet allocation algorithm, which is a very, very simple algorithm. So what it does, it basically generates this statistical model that allows you to understand how words are related, right? And it gives you a probabilistic mapping of topics so that it can identify. But the problem with this algorithm is that you really need to basically tweak your hyperparameter a lot in order to create meaningful topics. So you would effectively just get a bunch of titles out of this algorithm with some probabilities. And then when you look at these titles, all these words, you need to decide what topic it is, right? And that's normally not very easy. And sometimes, what you read in the names of the topics or the words themselves are quite different. So it's very difficult to make sense of it. Same problem we have with an NMF model. So these are basically statistical models. So when are they useful? So latent Dirichlet allocation, another thing that many people forget is that latent Dirichlet allocation algorithm requires you to work with independent observations. So for example, if you had text samples from, say, the same organization or the same group of people even, you cannot really apply this algorithm because it assumes that your observations are independent of each other. So you can't really apply it when you have the same the same organization. So basically when your data set is somehow related. Right, so when the observations in your data set are somehow related. You can't construct though an NMF algorithm with dependencies, so that's fine. And one of the main advantages of both of these models is they can work with relatively small sets, because remember, we do not need to train anything. We can have a relatively small set. And this is often a good thing because, so I always have these really funny stories about starting with a lot of data and distilling it to really small data. But basically, yeah, we recently looked at a really large data set with several 100 million observations. But then when we kind of cleansed it, we realized we only had 20 observations that we could work with. So naturally, you know, I mean, this is of course extreme case. It doesn't happen very often, but sometimes you have this problem when you basically did a lot of kind of cleansing work, and all of a sudden you find that this huge data set that you collected actually doesn't work anymore. And it's a small data set rather than a big data set. Okay, so basically, yeah, today I'm going to show you the data that we had was, first of all, independent. Second, it's a relatively small sample. I mean, we have still thousands and thousands of speech samples with a lot of words each, so sometimes up to 90 minutes of words. But we have really uneven split between timings of the speeches. And we have, like I said, a relatively small independent set that allows us to work with the LDA model, and we can't really apply anything else. So if you have a large data set, so I'm talking about hundreds of millions or millions of observations of samples of speech, you of course can go to these methods, so transformer methods like BERT, which is bidirectional transformer with masked language model and next structure prediction. You can then potentially go to Roberta, which does not have this next structure prediction, but works with mini batches of data and basically learns by looking at kind of stepwise functions. And we also have distilled BERT. So distilled BERT is effectively distilled BERT model, which approximates this large learning model with a small number of tools. So that's kind of like an economy version of BERT. And then we also have XLNet. So XLNet uses permutation-based modeling approach, but basically it's also bidirectional transformer. So when would you use these things? So you would use these things when you have a lot of verbal data, when you have, like I said, millions and millions of observations. So 100 million normally is something that we work with. It requires, so these models require large training sets and quite a lot of training time, apart from probably distilled BERT. So for example, if you had a BERT model, you would normally work with kind of a training set that is in the neighborhood of 16 gigabytes. If you go to Roberta, you need 160 gigabytes to obtain any meaningful results. With distilled BERT, you can go back to kind of the same as BERT, like 16 gigabytes. And XLNet, you can work with a large and a small version. So for the small version, it could be like 16 gigabytes. For a large version, you can work with 10 times bigger data. And also, you know, the timing kind of matches the requirement on the training set. So, for example, if you were to run a BERT model over 3 days, then Roberta will take you probably five times longer. I saw different estimates, different people say different things, but 4 to 5 times longer normally what you find. I mean, in my lab, we on average found that Roberta is about 5 times longer than BERT. Distilled BERT is, on the contrary, it's shorter, so it's only one. So, for example, it will take you, like if you were running BERT model over 4 days, then distilled BERT will only run for 1 day. So it's really nice. And actually, it's pretty accurate model because you only lose 4% of prediction power from it. So I highly recommend distilled BERT if you have a lot of data and you don't want to wait for days and you can compromise a little bit of quality, so it doesn't have to be as precise as Roberta. But it's a very, very nice tool, so distilled BERT. So consider it if you have a decent training set and decent number of observations in the data set. So it's quite useful. ExcelNet is a little bit weird. It's somewhere in between Bert and Roberta. So do not know what to quite say about it. I mean, it provides you a little bit of improvement over BERT, so probably say 7% improvement, but it's not as good as, for example, Roberta. So Roberta is used by Facebook and other companies that really want high precision in textual data. And on average, well, in my lab, we found that it provides you with about 12% improvement in prediction metrics. Again, online, I saw different numbers. Different people say different things. I saw kind of estimates between 2% improvement to 20% improvement. So like I said, in my lab, we find that it's about 12% improvement. But basically, in terms of what to use, okay, so if you have small data set, use LDA. It's okay, it works, and it gives you relatively precise topic modeling output. If you have decent data, then the best model is, of course, Roberta. Roberta gives you very precise result in terms of output, but yeah, you would have to wait. It requires a lot of time and quite a lot of effort. If you don't have time, then yeah, I really recommend using DistillBERT because it can run over a day and it can provide you a relatively nice result very quickly. So in terms of latent directly allocation, let's have a look at this very simple project that we have done very recently. And it's about, as I said before, Black females. So what we've done in this project, we first mined a female leadership speech. And basically, we mined it from two websites. The first website was Iowa State University political speech database, and the second was gifts of speech database. So we have, out of these two websites, we actually got data from over 2,500 public speeches. Obviously, in terms of words, we're talking about millions of words, right? And the data set was 757 female leaders, and the racial composition was basically this, with the majority of these women leaders being white, and about 97 women Black or African American. The first thing that we saw, these are basically, well, these are not all Black African American women in our data set, but the majority of them are here. So the first thing that we spotted is that usually, when we talk about a minority, we normally assume that this minority is only talking about their own problems, and potentially, people are not interested in global issues. But when we actually did the topic modeling exercise and put it into perspective, so this is what we found. So this graph shows all women in our data set overlaid with some historical events, and this is the topics that we found in the Black community. Of course, we have fewer observations for the Black community, but the cool thing about this is that the trends are exactly the same. So for example, you can see that many people in 19th century, so this is over 200 years, so it is quite dense, quite cool data set, and these are the topics that we obtained through topic modeling. And the cool thing about it is that many of these topics actually are global topics. They are reflecting the global goals that United Nations is setting. And from this, we actually figured out that, it's not that Black females are talking about just Black female problems, they're talking about global problems. One of the most prevalent topics in female leadership speech, and this is what we were really interested in, is actually resilience and perseverance. So women always talk about being resilient and persevering at their goals. And also they talk about service leadership. So this is quite a hot topic in recent years. And as you can see, I mean, the trend here and the trend here is almost exactly the same. And like I said, they talk about global goals. So, so effectively in this project, what we wanted to understand is why are these women great leaders? And we found that this is because they have great ideas, right? They talk about global goals. They really talk about problems that are important for all people, not just for their own community. And the interesting thing is that these global goals were identified by United Nations in 2015, so relatively recently, only 5 years ago. But these women talked about these goals way back from 19th century. So essentially what we also found with this data set is all these women were really ahead of time with their ideas, right? So it was really, really, really important that, they thought about global problems before the global community thought about them. So this is just to illustrate, just a couple of graphs to illustrate that there is no racial specialization in the topics. So here you can see this is outputs of regression analysis that we've done using the output from the topic modeling. And here, as you can see, if we have blue means underrepresentation of women, and red means good representation. So if we have a particular topic, when we have underrepresentation, then, for example, science and technology, so this is where women are underrepresented, then women in every racial group will be underrepresented, right? So it will be blue all the way through, right? So we do not have that, for example, white women are represented nicely to a significant extent in science and technology, and, for example, black females are not. So we actually have we do not have enough women in science and technology, irrespective of the race. However, where we see the differences is in occupations. So when we look at occupations, and this is again something that we mined from the data, and we looked at the topics that women are talking about, then we do see specialization. So effectively, for example, in politics, people are, for example, more likely to talk about service leadership, and so this is kind of one of the major topics for this particular group. So other groups will have different priorities. And just to show you that there is no clustering, so these are all women in our data set. And as you can see, I mean, if we had racial specialization by topic, we would observe that there were on kind of dots of one color would be sort of clustered. So we would observe kind of groupings of these women, but we don't see that. So we actually see that everyone kind of is mixed with everyone else, meaning that there are no racial differences. So what does this project tell us? It tells us that race, in principle, is a very ill-defined concept. And we often say that, okay, well, yeah, it's clear that people are like all people by all anthropological data go back to a single female. Right, so we know that, but the problem is that we still live in this in the world where people are treated differently because of the race. But this project shows that it really doesn't matter, and there is no specialization based on race that really defines people's preferences and leadership preferences in the world. And this data showcases it really well. I'm going to show you a second project really quickly. So this is where we were trying to understand, we looked at the most inclusive and diverse companies according to Thomson Reuters list. And we were trying to understand how leaders can change their organizations to become more inclusive and diverse by looking at leadership speech. So what CEOs of these companies were doing. So we started with Thomson Reuters. So this is so Thomson Reuters publishes a list of most inclusive and diverse companies. So every year you get 100 companies on the list. And it considers a wide variety of criteria. So these are all criteria that they consider. So the first thing that we do is we take an existing theory, which is a theory of cultural values, and we are trying to understand what type of values affect companies. So this is a theory that we have from psychology and sociology. It's called cultural value orientation theory. And the idea is that you have some countries that are more competitive. They would be located towards this pole here at the bottom right. And the more cooperative countries, they would be allocated more towards the upper left. And basically, yeah, what we do is we conduct a regression analysis, and what we find is that usually companies that have headquarters in more egalitarian states, they tend to be more inclusive and diverse. The second thing that we do is we mine the mission statements. And from these mission statements, we actually saw that the most inclusive and diverse companies that are rated high on the list, they actually do not talk about diversity and inclusion. They talk about outcomes, good outcomes for all people, not just for selective few. So they're not talking about, oh, we need to be inclusive and diverse. They say we are striving to deliver value to all people. Right. So, for example, we work to spread digital experience in the lives of people in their homes, cities, and businesses. Or they say, like Nestlé, good food, good life. Right. So they talk about delivering basically value to all people, not just to selective few people. So from these mission statements, we actually identified 4 main areas that we wanted to search. So here we conducted an unsupervised search and just tried to identify these topics. And then we identified these 4 topics: egalitarianism, public good, provision, so meaning that talking about the whole society, not just selective few groups, diversity and inclusivity, or diversity and inclusion. And then we have the data from the list from 2 years, 2018 and 2019. So in 2018, there are 105 companies because there are sometimes ties in the ranking, and there are exactly 100 companies in 2019. And all these companies could be split into 3 groups. There are companies that were present in this list in 2018 and dropped out in 2019. So 47 companies dropped out. Between 2018 and 2019, we had 58 companies that stayed on the list. And then we also have 42 companies that were not present in 2018 but appeared in 2019. So these are basically newcomers. So because we have all this topic modeling exercise, and like I said before, we are also using LDA here. So we can actually look at CEO statements from annual reports from 2017, 2018, and 2019 to understand why we have some companies drop out, some companies stay, and some companies come to the list. So basically, we look at how the previous year's CEO speech affects the outcome in the next year, because a CEO would normally determine the direction of movement for the next year. Right. And what we found here was that, again, instead of concentrating on inclusivity and diversity, these companies that are newcomers to the list that actually score very high, they tend to talk about public good. So So effectively, these companies do not talk about inclusion. Almost none of them talk about inclusion at all. They do talk about diversity, and newcomers do talk about diversity a lot. But as you can see, the main concentration is around public good. And here we can really explain why some companies, so companies that drop out, they do not talk about public goods practically at all. The companies that stay on the list, they have a slight increase, well, moderate increase in talking about public good. And companies that are newcomers, they talk about public good a lot. So this is the variable that really explains these differences between companies on this list. So what does this project tell us? Well, it tells us that if you are a leader of a company, if you are a CEO, stop talking about diversity and inclusion and start concentrating on public good provision, on being good to the community, being good to your customers. And you do not need to direct your staff in the sense of saying that, we all need to be inclusive and diverse. You need to explain to them and basically develop a company value that will say, company culture that will say that we need to deliver good outcomes to all people in the company, irrespective of their background. And we need to deliver good outcomes to the community. So that's the that's the pitch from this project. And so today I showed you very simple projects that we have conducted using very simple tools, this latent directly allocation algorithm, very simple as you can see, but we received some powerful results. And the main thing that I wanted to say is that, when you are doing data science projects, well, always think about methodology, because methodology is just as important as data, because data does not always have a best idea. It might have a good idea, but it doesn't always have the best idea. And only when you have a combination of good methodology and good data, you get actually really amazing outcome that can change the lives of people. So that's me. And I'm happy to take your questions, if there are any questions. Yeah, I don't know if you can hear me. I know that there is a little bit of delay, but if you want to ask any questions, thank you all for kind words. That's very, very good to hear. Yeah, ready to go to Q&A. Okay. How do you think this is the question from Subhatia? Hi, Subhatia. Good to hear from you. How do you think someone just starting can implement this? Yeah, like I said, the point of showing you this that you do not need to start with very sophisticated programs or sophisticated algorithms. You can actually start with something very, very simple like LDA, and initially think of a project that is so easy it's laughable, and just get, I guess, a hand of doing the topic modeling exercise. Like I said, there are a lot of tutorials. There are some fantastic tutorials on Towards Data Science on Medium. They're all free, and I can also recommend, if you want, to the community. I can also recommend some websites where you can find them. But basically, the point is to get into it, right? And not kind of when you start with a particular project, normally you need to start with a good idea and think about a problem, what it is that you're trying to do. If you know what it is that you're trying to do, you will always find a solution. It doesn't matter whether you're a beginner, you've never seen any data before. Well, I can tell you that I had, so I have quite a lot of students every year, and a couple of years ago, someone came to me who was a history major. So, so she came and she said, "Well, I want to do a project," and she had a very, very good idea about kind of smart cities and helping people with transport type of solutions in smart cities, and this was a rather computationally difficult project, and I was really concerned about this particular student because I thought, oh my God, how she's going to do it. But she was really passionate about this topic, and she found people who helped her with sort of the technical, with understanding of technical details. And she took advice from me, of course, she took advice from other people, and she started building the model. And initially, her model was also based on NLP, and actually was based on the latent Dirichlet algorithm. So now, of course, she does more sophisticated things, and currently she actually has her own company in Silicon Valley, which is very, very data-driven company. So my point is that it doesn't matter what major you are. It doesn't matter whether you're a beginner. Start with something. Start with an idea of what you want to do, and get even a very, very small data set. You don't have to start with big data. And then try to do something with this data set to obtain a result towards getting closer to your goal, towards answering the question that you want to answer. And step by step, you will make it more complex problem for yourself, and then you will actually develop your ability to solve problems. But you don't need to worry about whether you're a beginner or not a beginner. And naturally, I mean, these projects are combining behavioral science and data science, so you kind of need to have a knowledge of both. But if you think about human behavior, any problem related to human behavior, you can do a behavioral data science project, right? So it's like I said, the idea, for example, with female speech is a very simple idea. You just mine a few speeches from online databases, and you're trying to understand what female leaders are talking about, right? So it's a very, very simple idea, but and the means with which we achieve this result are very simple. So you don't need a lot of knowledge. You can just basically run an LDA. But you get a very powerful result. You actually, what you get is a 200-year mapping of female leadership speech. I think it's pretty cool. And so, yeah, you don't need to worry about being a beginner. Just do something. Just start. Would you suggest beginners to jump into simple mini projects straight away with the fundamental understanding of some foundational topics? Okay, so this is a very good question from Hrishita. Yes. Okay, so I personally think that you need a project. So you always need a practical problem. Try to get a practical problem and try to solve it. This is a very good strategy because it really will get you into the project. However, I think that you do need some understanding of mathematics behind it. It's important. It's not important at the starting point. Like I said, to start a data science project or behavioral data science project, you do not really need a lot of knowledge. You can work with online tutorials and some free tools that you can find online. But as you go along, you need to start understanding what is it that you are doing. So for that, you need some basic mathematics and some basic statistics. Without it, it's difficult. and it's important to have this understanding precisely for the things that I mentioned at the beginning. For example, you can have an inadequate training set for something that you're trying to do. But if you do not have a kind of the theoretical, methodological understanding of what exactly you're doing, you can actually get into serious problems. I mean, this problem actually is not only prevalent to beginners, but everybody. So people use inadequate training sets in different areas. For example, you probably heard about this. So we had this model that was recognizing whether you are gay or straight, right? Well, it was claimed that it recognized whether you're gay or straight. And the problem was that the training set came entirely from Tinder. But of course, when you're on Tinder, you're not exactly hiding your sexuality. So Tinder is an app where you go to get dates, right? So, but the problem was that people took this algorithm and then they applied it to professional photos that people took at work, or for example, LinkedIn photos. Of course, it's inappropriate, and the results that you will get will not be adequate. So to have this understanding, you need some theoretical understanding of what you are doing and some details about what you're doing. But, don't worry about it too much. Start a project and then gradually try to read about it. But you do need, eventually you will hit this, ceiling, and you would need to get a stats book or a math book, something like that, to be able to continue. Yeah, but it's a very good question. Yeah, in terms of, for example, where to get information about behavioral data science, we have a group, and we have also seminars. So there is a seminar. I don't know about whether it's convenient for your time zone, but on Monday we will have a seminar from Sudeep Bhatia, who does actually natural language processing work. And we have Alan Turing Institute seminars. If you want to attend them, just connect to me on LinkedIn. I will put you on our mailing list, and all seminars at the Alan Turing Institute are free and open to public. A lot of people think that you need some sort of membership or some special invitation to attend them. No, you don't. You can sign up. We have normally sign up pages on Eventbrite. You can go sign up and you will get an invite. You can come to a seminar, you can ask questions, and you can learn more about this whole discipline. And people do amazing work in it. So last week we had someone who was a physicist talk about how people form perceptions about events, and this week we will have Sudeep, well, on Monday we will have Sudeep talking about interesting work that he does between psychology and natural language processing, so quite exciting. So if you have time, it's 4 p.m. UK time or 11 a.m. Eastern time in the US. I'm not sure what time will be in your area, but if you're interested, do join us, and just connect to me on LinkedIn, and I will forward you the invite, or tell me I want to get on a mailing list. Yeah, so definitely we are open to public. Okay. Any other questions? Arian, you mentioned about top companies backing out with facial recognition projects, but wouldn't this slow down the growth in security surveillance in general? I think that generally this is an interesting time to do data science, because just a couple of years ago you could pretty much do anything. And people were not thinking about the ethical implications of it. But after we had issues with Cambridge Analytica and other kind of unethical use of data, and unethical use of algorithms, I think we are living in a time when internet in general and technology in particular and data science as a special case of that is becoming more and more heavily regulated. It doesn't mean that, I don't think it means that, people will stop doing facial recognition algorithms. They will keep doing them in different domains. But I think there will be a lot more regulation around it and a lot more ethical scrutiny. Because, there are really ways of kind of making these algorithms very damaging to people. For example, like I said before, we can actually write algorithms that are going to be very good for a particular minority group. But then, how do you segregate people into these minority groups in order to apply this algorithm? So you need some sort of process that will actually say, for example, let's just imagine that you're getting to a border control. So one idea some people had is that a security officer will kind of direct people. So they will look at them and segment them into groups, and then the algorithm will be applied doing facial recognition. Of course, this has even more ethical implications, because now we are placing all power into the hands of this officer who is going to say, okay, you are white and you're black and you are Asian, So this is like absolutely inappropriate. So yeah, I mean, I don't think that it means that the facial recognition algorithms will disappear, but I think that companies just no longer want to be, like big companies no longer want to be associated with this tech because of the ethical implications. And companies that really care about customers and really think that the customers are, can benefit from good understanding of technology would be also worried about the digital rights. So this is also the way for the companies to signal to the customers that, we care about your privacy. Well, think about the recent Apple ad, right? If you haven't seen it, have a look. There is a cool ad on YouTube, and it basically is all about privacy. So Apple is really saying, we care about your privacy. They signal it to the customer. And this is an important message in current environment. So this is why the big companies are trying to stay away of this kind of a little bit, gray areas of ethics, of AI ethics and tech ethics, data science ethics. But it doesn't mean that, these algorithms will disappear. I think there is also a lot of heterogeneity between, for example, China and the rest of the world. So in China, facial algorithms are very much there. I also heard that in Singapore now, as soon as you land, there will be this kind of constant surveillance system. I don't know whether that's true and when it is going to be implemented, but that's what I heard. So yeah, I mean, it still will be there, but I think it will be very heavily regulated. So that's probably why some companies do not want to do it. Okay. Another question from Hrishita. Since you were talking about inaccurate data sets, what are your thoughts on learners collecting their own data and building to model on it? Could that do more harm than good? It depends how you apply the data sets. For example, let's just say, so I currently work on a project where it's entirely within one company. So we collected our own training set in that company, and we're applying it to this company. Well, this is absolutely appropriate thing to do because you are applying it to the same environment where you collected the training set, right? Of course, if you have a problem like Amazon has, right? When they knew that there was a gender problem in their software engineering department and they didn't do anything about it. So they looked at it and they said, we just want to basically hire the same type of person. Well, that's a problem, right? So you need to have, basically have an understanding of the issues that you might have, for example, in hiring process to solve these problems. So you can have a bias set even when you're working within one company and applying it to the same company. The problems normally arise when you created a data set, especially this is true for synthetic sets, and then you train your data based on this data set, and then you go out of one domain or one context and try to apply it to a different context, right? So this is where we get big issues. Again, it depends, but generally, before you do something, you just need to understand what it is that you're trying to achieve, right? If you're just trying to say, okay, we like our processes here, we don't like our processes there, so we want to understand how we can equalize the efficiency across the company or across a particular context, in that case, it might be appropriate to collect your own kind of data set and apply it. But in other cases, it's not. Very often when I have doubts about my training data, I try to talk to first a domain expert. So, for example, if I'm training. So I recently did a project on COVID. So obviously I'm not a doctor, right? And not an epidemiologist by any standard. So what I've done was I talked to domain experts, and domain experts can help you identify these problematic areas. I remember with a friend of mine, we were doing an app that was tracking sunlight exposure. So people's exposure to sunlight. And we thought that it only depended on the color of the skin, right? But then when we talked to biologists and when we talked to doctors, they explained to us that it's a very complex area. You need to consider the amount of vitamin D that people have. And that does not only depend on the color of your skin, it depends on a lot of things. It depends on your biological clock, effectively. Did you sleep tonight? How much time did you sleep? So those types of things. Did you have enough rest? So these people can help you. So that's one. Second, in general, I recommend when you are in doubt about your training set, talk to someone who is not not working in your area, completely different. So, for example, talk to a lawyer or a philosopher or an ethicist or someone like that. Maybe even, people from humanities. They would have some ideas that you didn't even think about. And they will not come from a data science perspective. They will not come from a mathematical perspective. They will come from kind of more human perspective. And it will be really cool because then you will see, okay, so I haven't thought about this and I need to really address this issue. Because, for example, with a friend of mine, we wanted to do a food bank app. So we decided that, okay, there are food banks in the city and we want to create an app that would allow to direct people basically tell them where there is a kind of new stock of food so they could go and pick up things that they need. You would have thought really benign idea, a fantastic idea, right? You will help a lot of people. And then we started talking to some colleagues who are not in our field. So eventually we got to this philosopher ethicist colleague of mine, and they told us that, but you are creating dependencies for these people, because on the one hand, yes, you are telling them, how to more efficiently kind of go to a place to get help. But on the other hand, you're not doing anything for these people to get out of their situation, right? If they have a shortage of food, then perhaps we need to do something to lift them out from this situation so they no longer have this problem. And this particular app, all it would do is, these people would go from one place to the other, basically collecting freebies and not necessarily thinking in terms of what they can do for themselves. So, point is, talk to someone not from your field, and talk to someone who is a domain expert. Geraldine, how would you direct someone interested in pursuing career in data science? Well, I have a whole blog. So I have this series of interviews where I interview people that are data scientists, and I ask them precisely this question. What do you start with? How do you get there? And, I interviewed a lot of people on my channel who are all talking about data science career. And I can tell you that there is no preset path to data science. Everybody got to data science in a different way. So some started, like myself, from social science and got eventually into more mathematical research, more algorithmic modeling. Other people started as data scientists or computer scientists, and they got into kind of more interesting, more complex projects. So it really, there isn't a single path. I would say that the best thing to do is, again, to pick a problem you want to solve, right? So, think of, for example, Greta Thunberg, right? So I know that there is quite a lot of support that she has. But I mean, in the essence of it, this is a person that has this big dream, right? To make the world a better place, make it greener, make it more environmentally safe for everyone. And she's just pursuing her goal, right? So she's thinking about, how to get to this dream. So what are the technical means that can help me? So in that sense, I think the best way to start is to identify one problem in your community. It could be a problem in your community that you want to solve, right? For example, I want to get people to recycle more in my community, right? How do I do that? How do I achieve that? Or I want to make sure that, we decrease poverty, right? So how do I do that? So that's a big dream. And then you start partitioning it, and then you start thinking, how does technology come into it? Because, the thing is, data science is a very powerful tool, but it's a tool. It can make people more equal, but it can also make people more divided. Well, think about our electronic devices. Some people use Android, others use iPhone. So if you are an iPhone user, you would be a lot less exploited in terms of your data compared to an Android user, right? And this creates the divide. So for example, you could think of how to bridge this divide, how to make sure that people are not discriminated based on technology. But just remember that you can both harm and you can save with data science, and try to, I'm not saying that you should stop when you think that your technology might not always be used for the greater good. It's very difficult, because then you will not ever invent anything. You will not ever write any algorithm that will solve a problem. So instead, try to think of what you're trying to do and why you are doing this, right? So, and if you're going to think about why you are doing this, you will also think about all the drawbacks and potential benefits, and this is how you decide is it worthwhile or not. So. So effectively, pick a problem and have a dream. Just have a dream and think how you can apply data science to achieve your dream. I think it's this is the main thing. But I can tell you that people from all walks of life. I actually just talked to Curtis Fikes. He's an amazing person. He is one of the top writers in data science and AI for Medium. He started as a postman. Like, you see, like, it's a huge divide, between being a postman and being a data scientist. But he currently is one of the most sought after author online in data science. So and he started because he just was interested in some practical problems that he wanted to solve. And this is how he got into data science, started doing it, and he does it really well now. So, you can start anywhere as long as you have a dream. Yep. All right. I think we're probably almost there. So if there are any kind of last questions, I'm happy to take them. Other than that, just want to wish everyone good luck in your hack exercise. And I hope you picked really cool problems to solve, and looking forward to seeing the projects. Yeah, so Aryan is saying next time would surely ask a person out of the domain for project idea reviews. Yeah, do talk to domain experts. I forgot who said that, but like I interviewed someone who told me that data science is basically a service. Right? We as data scientists, we're providing a service to other people. So we cannot exist without other people. So normally in different domains, you have a problem, and you are coming as a data scientist with rather universal set of tools to be able to help them, right? And that's what you are doing as a data scientist. So definitely, yeah, domain expert knowledge is extremely important, and domain experts can help you understand what to do, especially when you are not sure about something. All right. So I guess with that, I'm going to switch off and maybe let Geraldine round up today's session. But thank you all for very cool questions. And like I said, I'm on all social media. I'm on LinkedIn, I'm on YouTube, and always happy to chat. If you have any further points or further questions, happy to answer them. Thanks so much. Thanks a lot. So yeah, I'm going to basically switch off and go to Geraldine. Thanks a lot. And thanks for the invitation, and good luck.
Okay, so thank you so much, ma'am, for your very enlightening and very intriguing session. We are so happy to have you here, and thank you for giving us the opportunity to connect with you as well. We look forward to welcoming you to be a part of many more of our future events, and keep in touch with you. So thank you, and thank you everyone for attending this session.